All right, so we've talked about finding z-scores when you're given area left. We've talked about finding z-scores when you're given area right. So the last thing to look at here is when we're given an area in between two z-scores. Now, I'll go ahead and tell you, you're only going to be looking at an area in between when your z-scores have the same absolute value, just one is positive and one is negative. It's always going to be a situation like this where it says find the z-score for which 96% lies in between a negative and a positive z. All right, it'll always be that same, because if not, you would not have enough information to solve it. So you'll notice what I did, first thing, is I sketched out my standard normal curve, and I approximated a negative z and a positive z with an area in between those at 96%. Now again, if I'm going to use my table, I have to have an area to the left. And the easiest way to convert this to an area left is to subtract from 1 and divide by 2. Anytime you're given an area in between, you can convert that to an area left if you subtract from 1 and divide by 2. So in this case, that means the area to the left that I'm going to use to find z is 0.02. All right, so I took the area left to my table. All right, 0.02 is what I want. I couldn't find the exact area, so again, I got as close as possible. And the corresponding z-score for that closest area was negative 2.05. Now again, when you're doing in between, once you find the negative z-score, then all you have to do is change the sign to find the other. It'll always be a situation of negative z and positive z. So my two z-scores with 96% in between are negative 2.05 and positive 2.05. Now, this is a situation where you have to be careful if you're using StatCrunch, mainly in making sure that you input the information correctly. So you kind of have a couple of options. One is to use the area left, that way you can stick with the standard calculator, but the other is just to switch to a between calculator, at which point you can put the area in exactly as it's given with an area in between. All right, so in that case, I would pull up my normal calculator. I would switch to the between calculator up there at the top. And then again, area goes to the right of the equal sign. The area in between here is 96%, so 0.96. And then I compute, there's my negative 2.05 and my positive 2.05. All right, so same thing here. Let's look at one from the homework, all right, where what we're given is an area in between. So notice here, there's that, negative z and positive z. And it says find the z-scores for which 28% of the area lies in between negative z and positive z. All right, so again, what I'm looking at here, 28% of the area is between negative z and positive z. All right, so I'm going to sketch it out. This doesn't have quite as large of an area in between. Our last one was 96%. This one's only 28%. So I'm going to pull these in a little bit. And again, this is just an approximation, so it doesn't have to be exactly to scale. But what I want to understand is that the area I'm given, 28%, is the area in between negative z and positive z. So if I'm going to go to my table, I need to convert this to an area left. And with in between, I do that by subtracting from 1 and dividing by 2. So again, I'm going to take that area in between that's given, I'm going to convert it to an area left, subtracting from 1 and dividing by 2. And that area left is what I'm going to use to find z. All right, and again, what that does here is it tells me the area over here would have a value of 0.36. And remember, that's the big thing, is that if you're going to use the table, you have to be looking up an area to the left of your value. All right, so I make that switch here. I go to my table, and I'm going to search for an area of 0.36. Now remember, this is less than half of the area, so I'm going to be looking for a negative z-score. And I'm going to search the areas to the left in here for an area of 0.3600. All right, so again, they start really small, increase as we go. So here are values around 0.1. Here are values starting at 0.2. Here's where our values of 0.3 are going to start. Now what I'm looking for is 0.3600. So you should see that's going to be in between 0.3594 and 0.3632. When I can't find the exact area, I want to choose the one that gets the closest. So 0.3594 is going to be closer to what I'm looking for than 0.3632. Therefore, I'm going to take the z-score that corresponds to that, which is negative 0.3 and 6 in the hundreds place. So this one's kind of a funny coincidence that it turns out to be kind of an equivalent z-score to the area. That doesn't usually happen. But again, this is where I want to be so careful about understanding what I have as an area, what I'm finding is a z-score. So these are two totally different pieces of information. And so answering my question here, using the area to the left, I have determined that the negative z-score is negative 0.36, and then thus the positive z-score is positive 0.36. And usually when you're entering your answers in MyStatLab, it will have you, if you got two answers, it will just have you enter with a comma. So I'm going to put in negative 0.36, comma, 0.36. Those are the two z-scores that I found with 28% in between. And same thing here, if I want to use StatCrunch, I would just want to make sure that I have the between calculator, put in the area in between, and when I hit compute, there's my negative 0.36 and my positive 0.36. Now, I do just want to make a little note for you. You're going to see this referenced in some of the homework problems. There'll be a little note that says if you cannot find one area that gets the closest to what you want, then you will need to average the corresponding z-scores. So watch out for that. If you're ever looking at your table and you're trying to pick the area that gets the closest, but you have areas where essentially they tie for the closest. A good example of this is going to be right here. If we were looking for an area of 0.05, we could not pick one of these over the other because they're equally close to what we want. And so what we would do in that case is we would take an average of the z-scores, add them together, divide by 2, and we would use a z-score of negative 1.645. All right, you only see that certain places in the table, so normally it's just pick the one that gets the closest. But if you can't, this is how you handle it, which is just averaging z-scores. All right, so now what I want you to do is go back to your practice problems and look specifically at questions where you are given the area in between and use one of these methods to find the corresponding z-scores.